Okay, so this comes out to be about 10 years. Okay? All right, for number 2. A current census shows that the population of a city is 3.5 million. Using the formula given here, find the expected value or find the expected population of the city in 30 years if the growth rate is 1.5% per year. Okay, so currently my initial value, A or P, however you want to write it, is 3.5 million. All right, my rate of growth per year, so that tells me which formula to use, would be 1.5%. As a decimal, that's 0.015. All right, and then my time would be 30 years. Okay, now in this case, if they're telling me to use y equals a times e to the rt, then that's what I'll use. So 3.5, now I'm not going to write out million. You just need to know that your final answer would be in millions. So 3.5 times e raised to the rate times time. All right, I'm coming out that it's about 5.5-ish if you round. So that would be 5.5 million. Okay, for 3. All right, population P in thousands of a city can be modeled by the following equation. All right, where T is the time in years. In how many years, so that lets me know that I'm looking for T, will the population of the city be 120,000? So 120,000 is like your end goal, right? In how many years will I stop at 120,000? Now, notice that it's already measuring your population in thousands. So similarly, when I plug in 120,000, I'm just going to write it as 120 because it's already being measured in thousands. Okay? So if my formula currently says this, as shown in the problem, all right, and I'm looking for when will it be 120,000. All right, I would start first by dividing by 80. All right, which is going to give me 1.5. Okay, now we talked yesterday about how to rewrite / solve equations with base E. So if I take the ln of both sides, right, because the only way I can get rid of the E is to natural log. So ln of 1.5, ln of E to the 0, 1.5. All right, natural log cancels, okay? So what I have is 1.5 equals 0.015 t. All right, oh, I'm sorry. Well, back up. Made a mistake. Forget what I just said. All right, the ln of the E cancels, but not on both sides. Just kidding. So now you have the natural log of 1.5 is equal to this. So in order to solve for t, I would need to divide by that decimal. Okay? So if you type that in your calculator, remember your ln button is just like the third one up from the bottom on the left-hand side. Since we're rounding in number of people, I would just round to like the nearest whole number, or sorry, this is number of years. So round to the nearest whole, I'm getting about 27 years. Okay. All right, for 4. All right, how many days will it take a culture of bacteria to increase from 2,000 to 50,000 if the growth rate per day is 93.2%? All right, well, I know that I'm growing, so I know that means I need to use my growth formula. A times 1 plus R raised to the T. Okay? All right, so my starting value is 2,000. And my end value, right, I'm trying to get to 50,000. My growth rate per day is 93.2%, so as a decimal, that'd be 0.932. And I'm looking for T. after how many days? All right, so 50,000 equals 2,000 times 1 plus 0.932 raised to the t. All right, so again, I would divide both sides by 2,000 first. All right, which is going to bring me down to 25. I'm going to go ahead and add inside the parentheses. So that's 1.932 raised to the t. So again, you can either log both sides, or if I were to rewrite that in exponential form, right, that'd be log base 25 of 1.932 equals t. So when I type that into my calculator, right, you do log of 1.9 divided by log 25. And I'm coming out that this should be about 4.9 days. So really just shy of 5 days. It doesn't really ask us what to round to, so I would take either. That'd be fine. Okay. All right, 5. The element plutonium-239 is a highly radioactive element. If the half-life of the element is 24,360 years, what is the value of K for this element? All right, so here they give me my formula. So even though K is different, right, A still means initial, T still means time, so your K is kind of like your rate, okay? All right, so now this one's worded a little bit differently because it really doesn't give us any information other than what the half-life ends up being. All right, so think about it this way. If an element has a half-life, then that's like how long its life is halfway. So initially, the element has all of its life, right? It is a full, lively element at like one whole total element. So in other words, think of your initial as 1, right? You're starting with 1 element, okay? Your end, right, what you're going to finish with is half of the element because it has a half-life. So that'd be half or 0.5, however you want to write it, okay? All right, your T is 24,000 years. And I'm looking for K. So if I fill all that information in, I've got 0.5 is equal to 1 times E raised to the K times 24,360. Okay, now if I divide by 1, that's still just the same as half. So really, you could rewrite it as this. Okay? Again, in order to get rid of the E, I have to take the natural log of both sides. So the natural log of 0.5, the natural log of E raised to that massive number. Natural log of E cancels. So now you have natural log of a half is equal to 24,360 times K. So if I divide both sides by 24,360, now you could do these all like in distinct steps. I think it's just as easy to type all that into your calculator at once, okay? But what you should notice is you end up getting like a very, very small decimal, okay? So for instance, if I'm typing in, all right, the natural log of 0.5 divided by 24,360. Remember, that E means that you have this number, but you have 5 zeros in front of it. So that's really like negative 0.0000002, all of this. So in other words, a very, very small number, okay? I would just write this as negative 2.85, I would just round it up here, times 10 to the negative 5. Remember, because we count in bases of 10, that's kind of like your scientific notation, okay? So my K value, negative 2.85 times 10 to the negative 5. I don't know if you have one like that on your test, but if you do, that's how I would write it. Very small number. Okay? All right, 6, a GPS system uses satellite information to locate ground position. If Jim Bob's surveying team bought a GPS for $12,500, the GPS depreciated, so that's a decay, by a fixed rate of 6% and is now worth $8,600. How long ago did they buy the GPS system? Okay. Your decay formula, remember, is the same as your growth except you subtract your rate every time. So I started with, initially, a GPS that was $12,500, but I'm ending with a GPS that's $8,600. My rate is 0.06, and I'm looking for time. How long ago did we buy it? All right, so 8,600 equals 1,250 times 1 minus 0.06 raised to the t. Same thing, divide by 12,500. And I'm getting that that's like 0.688 if I just round to 3. Okay? 1 minus 0.06 is 0.94 raised to the t. All right? Same thing, if I were to rewrite that, you would have log base 0.94 of 0.688 equals t. Type that into your calculator, right? Log of 0.688 divided by log of 0.94. And I'm coming out with that that's about 6 years. All right? 7. In a lab, an organism grows from 100 to 250 in 8 hours. What is the hourly growth rate in the growth formula given here? All right, so this time I'm looking for the rate, right? What is the hourly growth rate? So I need to find R. My initial is I'm starting at 100. My ending is 250. And my time is 8 hours. All right, so I've got 250 equals 100 times 1 plus R raised to the 8. All right, I can start by dividing by 100, in which case I have 2.5. Now, in order to get rid of the 8 exponent, I need to take the 8th root, okay? So 8th root to make those cancel. So in case you don't remember, when you're in your calculator, if you're trying to take a root that's not a cube that's already written, right, you need to press 8, and then you would need to go to math down to number 5 so that indicates you're taking a root with an index of 8, okay? So I'm taking the 8th root of 2.5, and we get this long decimal. All right, so that's about 1.1214 if I round to 4 is equal to 1 plus R. So then if I subtract 1, my rate would be 0.1214, or as a percentage, it's about 12.14%.